Hello, class. Continue the recorded lectures for Chapter 4, Linear Regression Analysis. And we're going back to the first section, which shows you how to compute this correlation coefficient. And the idea of the correlation coefficient, again, you could try to do it by hand, very tedious. Technology helps, or you could use a spreadsheet / calculator to calculate the correlation coefficient, which stands for R. And R is the relationship that will give you how well your equation will match the data. And so let's walk through at least the initial equation and kind of show you the craziness that we're going to get into. So by the definition of the correlation coefficient, it's this crazy equation that we have done here. And basically, the idea is that this numerical measure of strength of the linear relationship. So the idea is that the number is close to 1, absolute value of 1, it means it's really strong. And if the number is close to 0, that means it's very weak. And it's the idea of taking each one of the ordered pairs with calculating the sample mean and this of both X and Y, and the sample standard deviation, and then the sample size, and you do this calculation of R. And so you could see it's like two z-scores multiplied together, right? And then divided by n-1, which we talked about as degrees of freedom, etc. And so, as I said, if you tried to do this by hand, it's very tedious. But if you had a spreadsheet, you could set up the columns and do it. So if you take a look at the data that we've been dealing with throughout this chapter, this is, again, the data for the size of the home versus the price of the home. And if you calculate the mean of the size of the home, it's 2891. The mean for the selling price is 447. And then here are our two standard deviations. And you could see accordingly in the calculation. And so when you do that calculation, it's a little bit crazy, right? You'd walk through and you would generate these two columns, multiply them together, and then calculate it this way. And you could do that on the spreadsheet for sure. And tedious, but not super hard. But the way we are going to do it is either using the spreadsheet or using the calculator. And if you go back and look at the calculator output of that regression analysis that we did in the previous recorded lecture, you could see we got the A value and the B value. But it also gives you what's called R and R squared. And we're going to talk about R first, and that is the correlation coefficient. And so you can see this one is 0.9. So what will happen is that if the slope is positive, the correlation coefficient will be positive. And the slope is negative, the correlation coefficient will be negative. So in this case, it's positive. And so we have a positive R value as well. That's a very good R value. So that gives you a good confidence level, so to speak, that this value is going, or this equation matches the data pretty well. And so again, if you go back to look at the regression analysis that we did on the calculator, and we did all that, right? You could see that when we had the output of that, you could see here is our 0.9 for that. And so highly recommend using one of these two technologies, right? The other one is using Excel. And so given the data, Excel has a function called CORREL, correlation relationship. And so if you went to the spreadsheet, and you can see I have it right here. But if you wanted to find the R, you would go up here, more functions, and then core REL, click on that, and you can see two inputs. Array 1 is the X values, or the horizontal axis. Array 2 is the y value, and that is the vertical axis. And you click OK, and up comes the number again. So again, pick your poison, but this is an important number because this will dictate if you're going to use this equation or not. And what I mean by that is that if that number is real close to 0, you might not want to use this model. It's not going to be a very good predictor. And if the number is real close to 1, or if the slope's negative -1, you probably do want to use it. And so that's a very important calculation to do when you're doing these. Okay. So another thing that's important again is this relationship, and this slide is very good. So slide 16 here, it gives you that R is going to be positive if the slope's positive, and R is negative, slope negative. And again, as I said, ideally the number closer to the absolute value of 1, the better the correlation, and the number closer to 0 means not so good correlation. So before we end this one, I do want to point this out because this is important, is correlation doesn't really mean causation, right? Just because you statistically have a correlation doesn't mean there's a good cause and effect with regards to that. And this is kind of a funny example. So I like to use this. I took this right out of the book. It says a group of elementary school children took a vocabulary test, and it turned out children with bigger feet tend to get a higher score. And if you did the analysis, you would see that there is that correlation. But hopefully we all agree that there's no causation that just because you have big feet means you're good with words, right? And so that's what we mean by that. So sometimes you have to make sure that you know what you're looking at and interpret the statistical data and not just run the calculation and then assume something, right? So that's what we mean by that. So that ends the recorded lecture for the correlation coefficient. And we're going to have one more to go, and this will deal with actual using the equation for predictions and wrapping up chapter 4.